Okay, this is an extension activity based on things that we've previously learned. So our key idea in this part of the lesson is to solve equations we're going to use the graph, but I'm also going to go through and show you how to use the equation to solve without using the graph. So to solve the equation ax plus b equals cx plus d, which is our extension equation, we're going to write the two linear equations so that they're equal to each other. So this is going to be very similar to what we did when we were solving systems of equations algebraically. Okay, so we're just going to kind of combine the two together. So we're going to go through and write them out as equal to each other, and then we're going to graph the system of linear equations. The value for x of the solution of the system of linear equations is the solution to our equation of ax plus b equals cx plus d. So basically we're going to go through, we're going to graph these, or we're going to solve using our algebraic method. And then our x portion of our solution is going to be our answer for this equation, which is our extension equation. Okay, this is a little bit higher level, so it's an introductory. So this is something that I will not assess you on, but I still want you to practice it. Okay, so if we go through and we actually graph this equation, and I'm going to show you both methods. If we go through and graph it, really what this is saying y equals x minus 2 and y equals negative 1/2 x plus 1. So really this equation that's up above is those two equations. In the past, what we did back in our previous lesson solving algebraically is they would give us these two equations and we would transform them into that equation. Okay, now what we're doing is just the reversal. So it's kind of having us work the opposite of what we've previously done, a little bit of an extension. Okay, so if I go through and graph this, well, when I graph, I always start at my back end. So this is reviewing stuff from a previous chapter. I'm going to go to -2 on my y line and put my dot. And then no number in front of the x means it's a 1. So my slope is 1 over 1. So up 1 over 1. Up 1 over 1, up 1 over 1. And I'm going to continue that pattern also backwards. So from my -2 point, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Now, if I have to extend that further, I will. But for now, we'll go ahead and just do it that far up. Okay? So my second equation, so we did that one in blue. We're going to do in black. So we're going to go, actually, I'll change the color. We'll do yellow. Okay, so we're going to go ahead and start at +1, put our dot on our y line, and then we're going to do our slope of negative, so down 1 over 2. So down 1 over 2 puts me right there. All right, there's where our 2 points intersected, or our 2 lines intersected. Okay, so if we were doing systems of equations, well, our solution would be our x was +2 and our y was 0. So in this situation, because of the equation they wanted us to go through and use, we only have to give the x value. That is going to be the solution for our whole equation. So our final answer is going to be x equals 2. Okay, that's going through and solving it by graphing it. Okay, so I'm just going to go through and actually, for those of you that are comfortable using that solving for x, because we just need the x value, is we could actually go through and use this equation. We should still get down to the same answer. Graphing it, we visually get to see it. Solving it to solve for x sometimes is not as comfortable for people. So the graph is a little bit easier because they get to physically see the answer. So if I were to go through and solve for x, I'm going to get my x's to one side. So I'm going to go ahead and move this plus 1/2 x plus 1/2 x. Remember, no number means a 1. I now have 1.5 x. If you want to change that to 1.5, you can do that too. -2 equals, I still have a +1. So then we would go +2, +2. 1.5, so I'm going to change this to 1.5x just because I know I'm going to be having to solve for x anyway, equals 3. So now if I divide by 1.5 to get x by itself, 3 divided by 1.5 is still going to give me x equals 2. So take note here, it still went through and gave us the same answer. Ultimately, we're just trying to solve for x in this equation. So you can kind of pick, I know the book asks you to graph it. If you want to graph it, you may. If you'd rather work it out algebraically like I did there in blue, you can go ahead and do that too. All right, so let's go ahead and try another one. So not a whole lot of new in this lesson, just having you practice another concept. Okay, so once again, if you're going to do the graphing, you're thinking of these as two separate equations. So y equals 1/2 x plus 4 and y equals negative 1x minus 11. Okay, so we're going to go ahead and graph both of those. So I'll graph one of them in red. So positive 4, I'm going to go up to 4, put my dot. And then up 1 over 2 for my slope, up 1 over 2, up 1 over 2, and I'll go ahead and work backwards off of that 2. So down 1 over 2 from my 4, down 1 over 2, down 1 over 2. Okay, so if I need to continue it later, I will. All right, so now let's go ahead and graph. We'll do this one in blue. Okay, so I'm going to go to negative 11, which my graph's not quite big enough, so I'll kind of guesstimate it. There's my negative 11. And I'm going to go down 1 over 1. So down 1 over 1's kind of about there. So I'm going to go ahead and work up 1 and over to the right. I'm going to work everything backwards because I can tell it's going to cross somewhere over in here. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and continue that pattern. You can see the pattern pretty easy. We're doing a perfect diagonal. All right, let's see. Okay, whoops, I didn't get that one over far enough. Okay, so I'm going to stop it there, but I'm going to continue my red one. I can see right now they're going to cross somewhere in here, right? So I'm just going to continue the pattern off of my red. So I'm going to continue to go down 1 over 2, down 1 over 2. There's where they intersect, was right here. So the coordinates of that, well, I would go over to negative 10 and down to negative 1. So we have to remember in this equation, they only want the x. So I just found out that my solution is x equals negative 10. Okay, so that's graphing it. Now I'll go ahead and check it. You know, sometimes that counting backwards off the graph is confusing for people. So maybe they would prefer to go through and actually solve it using the algebraic method. Okay, so the nice thing is they already have it set up for us. They already have it set up where it's the x's. We just want to work to get the x's to one side. So I'm going to move this x plus 1x. I always like to get rid of my negative x's. Okay, so I have 1.5 x plus 4 equals negative 11. So I'm going to do a minus 4, and I forgot my x there. Whoops, and then I wrote minus 5. Okay, minus 4. So 2 negatives make it still a negative, but I'm going to add, so negative 15. And then I'm going to change this to its decimal form of 1.5 x. So we'll divide by 1.5. Divide by 1.5, and of course you can use a calculator if you need to. I can tell it's going to be a negative because there's only one negative. 15 divided by 1.5 is 10. So I still get x equals negative 10. Okay, your comfort level. You have to decide what you're comfortable with. In this situation, it's a new form of an equation. They only need us to give the x value. So we don't have to go through and find y. We could go through and find y. If we needed to, we would just substitute in to one of these two parts of the equation what our x answer is. They're not asking for that. They only want the y, or they only want the x. Okay. All right, so here, a little bit tricky, but we have y equals 3x minus 4. and y equals a negative 1x. The reason I say a little tricky, sometimes kids get confused when it comes to graphing that. Remember, if there's no number in the back, it's the same as saying a plus 0. Okay, so we'll go ahead and graph this one in black. So my starting point, my y-intercept is going to be right here. My positive, or my 0, sorry. Then I'm going to go down 1 over 1. Down 1 over 1 because it's a negative slope. So we can see that slope very easily. We'll do a few going above there. And then if I have to extend it later, I will. Okay, so now my other equation, we'll go ahead and do that one in red. We're going to go to negative 4, put our dot. And then it's up 3 over 1. Up 3, 1, 2, 3 over 1. There's where I land. I'm already intersecting, so I don't really need to extend it out any further. So there, my xy is, well, over to 1, down to negative 1. So my solution for this equation, I only need the x. So x equals 1. Okay, if we wanted to solve it algebraically, we could do that also. And this is where you get to choose. I know the book tells you to do it, graphing it. If you would rather do it algebraically, that's perfectly fine. So I have 3x minus 4 equals a negative 1x. Now I usually like to get rid of my negatives, but because my x is isolated there, I'm going to go ahead and get rid of this 3x by subtracting. We're doing a negative 3x. I get negative 4 equals negative 4x. Divide by negative 4. Divide by negative 4. Negative 4 divided by negative 4 still gives me x equals 1. Okay, to me, algebraically solving it is faster than graphing it, but that's because I'm comfortable with solving it with algebra. Some people are not. They would prefer to see the visual just to get their confidence. Okay, let's try one more. All right, we have a negative x plus 1 and a negative 1/4 x minus a half. So this one's kind of tricky, in my opinion, to graph. Why? Because of this equation. Okay, you guys are used to always graphing on a whole number. Now we can graph this, and I'll prove to you that we can graph it. Sometimes it's hard then to count out your slope from that. So if I were to graph this one, I would go to negative a half, which is right in the middle here. And then I would go following this slope of down 1 over 4. So I have to remember when I go down 1, I have to go down to the middle of the next box and then over 4. Same thing, down 1 to the middle of the next box over 4. And I'll continue that in the other direction. So up 1 to the next box over 4. Up 1 to the next box over 4. Okay, so there's that equation. That's probably the reason I would prefer to do this one algebraically. The other equation was y equals negative 1x plus 1. So I'm going to go to positive 1. And then I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Okay, so we can see it looks like they're intersecting, even though it doesn't land on the same point right there. Okay, so I second guessing myself. I'm not landing exactly on one point. So this might be one that I prefer. So right now I'm saying that x equals 2. Because that would be a 2 comma negative 1 solution, and I only need the x. But I'm going to double check myself because just confidence-wise, I'm more comfortable doing the algebraic equation. So we're going to find out what x is. So let's see, I would probably move this x plus 1x to get rid of it. If you want to change those to decimals, you can. So this is a 1 equals a negative 4th, which would be 0.25. This is going to give me 0.75x or 3/4 x minus, I'm going to change this to 0.5. So we'll do a plus 0.5 plus 0.5. I get 1.5 here equals 0.75x. So divide by 0.75. Divide by 0.75. So 1.5 divided by 0.75 gives me 2. If I do that on my calculator, that's what I got. And I did get that here too. I just wasn't I was kind of second guessing myself. And if I were to draw my lines, I would see that that's where they're intersecting. But sometimes when we don't see it land exactly on the other coordinate point, we sometimes think that we don't have it correct. So I just proved doing this algebraically that x does equal 2. So that's it for our 5.4 extension. There are some word problems in this also. You'll go ahead and use the book to kind of practice some of those. Once again, I'm not going to assess you on this. It's more or less I just want you practicing the skill to try it out. So good luck with this part of the extension of 5.4.